This is on mathheals.com, where you can find more links to math YouTube videos and computer science. And let's take a look at two population proportions. And we'll be dealing with claims, be dealing with confidence intervals, sample size, a little bit of everything. Sampling method is independent when the individuals selected for one sample do not dictate which individuals will be in a second sample. A sampling method is dependent when the individuals selected to be in one sample are used to determine individuals in the second sample. Dependent samples are often referred to as matched pair samples. It is possible for an individual to be matched against him or herself. We'll talk more about that later. Sampling distribution is the difference between two proportions. Suppose a simple random sample size N1 is taken from a population where X1 of the individuals have a specified characteristic. And a simple random sample of size N2 is independently taken from a different population where X2 of the individuals have a specified characteristics. So you got two different samples, and X represents how many meet whatever your definition is of success. Whatever you're studying, that is. Now the sampling distribution of p hat sub 1 minus p hat sub 2, where p hat sub 1 is equal to x1 over n1, and p hat sub 2 is equal to x2 over n2, is approximately normal, with mean mu sub p1 minus p hat sub 1 minus p hat sub 2 equals p1 minus p2, and the standard deviation sigma sub p hat 1 minus p hat 2 is equal to square root of p1 times 1 minus p1 all over n1 plus p2 times 1 minus p2 all over n2, provided that and this is where you got n times p times 1 minus p is greater than or equal to 10 for both populations, both samples you've done. And each sample size is no more than 5% of the population size. Well, if those are true, then the standardized version of p hat sub 1 minus p hat sub 2 is then written in this form. This puts it back to our standard normal distribution, so we can then use our table or use some just of our normal distributions. Well, hypothesis test regarding the difference between two population proportions. First off, samples are independently obtained using simple random sampling or through randomized experiment. And n times p times 1 minus p for both populations is, n times p hat times 1 minus p hat is greater than or equal to 10 for both populations / samples. Each sample size is no more than 5% of the population size. Now we're going to assume that these are true. I've made up some problems, but whether they actually meet this or not is probably questionable. I'm not going to go over these next steps. I'll skip down. Let's go to our claim. I made this up, so probably isn't very good. I'm not very good at making these problems up. Okay, in testing a new drug, Xyzar, there was a concern of migraines occurring during usage. Obviously, I can't spell. During usage, 300 out of the 1,000 people in the Xyzar group. Okay, let me put that here. Xyzar. 300 experienced migraines. So x is equal to x1 is equal to 300, and n1 is equal to 1,000. So that's our Xyzar group. And then while 250 out of 1,000 people in the placebo group experienced migraines. So this is our placebo group, our sugar pill. So we got x2 is equal to 250, and n2 is equal to, I think it was 1,000, wasn't it? Yeah. Let me write that one a little bit better. It's kind of sloppy. 300. There we go. Let's see, is the proportion of people getting migraines greater than for those taking Xyzar than those taking a placebo? So their claim is the proportion of Xyzar, I'll do P for proportion, is greater than placebo. Now, if I put these in the notation, I said this is 1, and these are sub 2s, so this would be saying P sub 1 is greater than P sub 2. At alpha is equal to 0.05. Okay, now this first one, if I can get back up here, there we go, will be the classical approach using the calculator. So classical T83 84. Okay, step 1, write down a shortened version of the claim. We did that. Step 2, come up with a null and alternate hypothesis. Greater than is going to be on H1. If that's greater than, then this will be less than or equal to. The only symbols you can put on H1 is less than, greater than, or not equal to. And the only symbols you can put on H0 are less than or equal to, greater than equal to, or equal to. Now again, the book will always put an equals on H0, but I like my notation better. See if claim matches H0 or H1. Well, this is a greater than. The greater than went there, so this matches H1. Okay, draw the picture. We got a greater than on H1. Greater than on H1 means right tail. Okay. Oops. Not sure what that was. Find a critical values, use 9V norm. Oh, we got to split our alpha. 5% here, 95% here. So to find this critical value, we'll use INV norm. Now remember, INV norm is always based upon the area to the left. Well, the area to the left is the 0.95. And just getting this ready. There we go. Okay. So I'll do second vars. Actually, let me clear that out. Second vars, INV norm, so pick third one, and 0.95. And we get 1.645. That's our critical value. So INV norm 0.95. Give us that. Now our test statistic. Yeah, if I get back there, it says to use 2-prop z-test. So 2-prop z-test. So let's go take a look at that. If I press stat, go over to test, 2-prop z-test. It's like number 6 on my calculator. That stands for two proportion, 2 sample, and the prop is proportion, and so forth. N1, there it is. 1,000 or X1, 300. 1,000. And 250 and 1,000. So that's what they give us. The symbol on H1 is a greater than, so I want to write her over, make sure the greater than is highlighted, so I'll press enter on it. Mine was already highlighted. And then I'll down arrow to calculate and press enter. Now the z equals is our test statistic, so it's 2.50. Now this is the number line. Here's 1.645, so 2.50 would fall over here in the right tail. So for a conclusion, if test statistic falls in a tail, which it does, it says reject H naught. So we're going to reject H naught, which means we'll accept H1. Most books will use the word do not reject. And our claim matches H1, so whatever we say about H1 is what we say about our claim. We accepted H1, so we'll accept our claim. Okay. Now we're going to do this one again. We're going to actually do it 4 different ways. This is classical by hand. And I'm going to grab a drink here. And let's see, our claim is still P Zeiser is greater than placebo. So P1 is greater than P2. Okay, classical by hand. Let me find that. Here it is. Okay, step 1, write down a shortened version of claim. Did that. Step 2, come up with a null and alternate hypothesis. That's the same as the previous one. So I won't go through those steps again. Draw a picture. It's a right tail. Split your alpha into your tails, so put the entire 5% in our tail since we only have one tail. And if that's 5%, this is 95%. Okay. And then it says find the critical values. Use the standard normal distribution table. Okay. So let's go look that up. Now, it's based upon the area to the left. So I'm looking at this critical value. The area to the left is a 0.95. So I'm going to look at my table here for 0.95. And I'm looking for it in the middle. I'm looking for the value that's closest to it. Or exact, if I can find it, but I won't be that lucky. Here's 0.9495, and here's 0.9505. It's halfway in between these. So I come over here, first part is 1.6. And it's halfway in between this value and this value. If I go up from here, this is 0.04 and this is 0.05. So this will be 4 or 5. And that's our critical value. Now our test statistic is a formula. This one right here. So we got Z naught is equal to P hat sub 1 minus P hat sub 2 over square root of P hat times 1 minus P hat, then the square root of 1 over N1 plus 1 over N2. Now, P hat sub 1 is equal to X1 over N1, which is equal to 300 over 1,000, which gives us 0.3. Our P hat sub 2 is equal to X2 over N2, which is 250 over 1,000, which is 0.25. And then our P hat, they give us a formula right here, X1 plus X2 over N1 plus N2. So X1 plus X2 over N1 plus N2. Well, X1 was 300 plus X2, which was 250, N1, which is 1,000, plus N2, which is 1,000. So that gives us 550 divided by 2,000. 550 divided by 2,000. 0.275. Okay. So that's what we kind of do over on the side there. So then Z naught is equal to P hat 1, P hat sub 1, which is 0.3, minus P hat sub 2, which is 0.25, divided by square root of 0.275 times 1 minus 0.275. Then square root of 1 over 1,000 plus 1 over 1,000. So let's go plug this in. Key part is put parentheses around top, parentheses around the bottom when you plug it in. So I got 0.3 minus 0.25. Close parentheses divided by beginning parentheses and then the square root. So second x squared 0.275 times beginning parentheses 1 minus 0.275 close parentheses. That's closing parentheses on the 1 minus 2.75. I need another closing parentheses for the square root. Then I have another square root. I'll do times just in case. Second x squared, and then 1 divided by 1,000 plus 1 divided by 1,000. Enter. 2.50. Probably looks familiar, doesn't it? 2.50, that's what we just got with the calculator. So if I look at this like a number line, 2.50 would fall over here in the right tail. So our conclusion would be we reject H naught and we accept H1 and accept the claim. Like that. And let's look at the problem again. Actually, separate these with red. There we go. Okay, number one, part 3. This is going to be the p-value approach. And specifically using a T83-84. And let me see, I think it was the proportion of the Xizar is greater than the placebo, which was P1 is greater than P2. Okay. Here's p-value approach using the TI3, TI4. Says write down a shortened version of the claim. Did that. Come up with a null and alternate hypothesis. So P1 is greater than P2 will be on H1, and this will be P1 is less than or equal to P2. Our claim matches H1. Step 4, find a p-value. Use 2-prop z-test. Now, our 2-prop z-test, if I go to stat and go to tests. 2prop z-test. We've been in there already. Basically, fill in your x's, fill in your n's. You choose the appropriate symbol, and then when you choose calculate, it'll give you the p-value. So p-value is equal to 0.0061. Now remember what the alpha was in this problem. I don't, but assuming you do. There it is. Alpha is 5%. So alpha was our 5%. Well, this says if your p-value is less than alpha, p-value is less than alpha, isn't it? It says reject H0. So for our conclusion here, we'll reject H0, which means we'll accept H1. And since our claim matches H1, that means we'll accept our claim. P-value is pretty nice if you got technology to give you the p-value. Problem is when you don't have the technology to give you the p-value, sometimes it's a real pain to get that. Okay, part 4. Let's find the using the p-value approach by hand. Okay, so p-value approach. And this is by hand. Okay, our claim is that Xizar, hopefully that isn't actually a drug or something. I made up the name. So P1 is greater than P2. Should be a drug though. Xizar. All this is still the same. I'm not going over that. I'm just writing it down again. Okay, claim matches H1. Okay. Well, now we're down to step 4. It says find this. Well, that looks familiar, doesn't it? That's what we just found up above here. So I'm not gonna show all the well, actually, let me write it down. I'm about out of space. So I'm going to use that same formula as up above. I won't put all the detail in there. I'll just write it down and then write down the answers. So we got 0.3 minus 0.25 over square root of 0.275 times 1 minus 0.275. And then square root times the square root of 1 over 1,000 plus 1 over 1,000. And that's going to give us 2.50, same as above. Okay. Now what we do with that is a little bit different now. It says look up the z-score from step 4 in a standard normal distribution table and find the value from the table, the VFT. And keep in mind this right here is a right tail. We saw it up above up here. Okay, 2.50. Here's 2.5, and then the hundreds place being 0 is this first column. So 2.50 is 0.9938. 0.9938. And VFT, value from table. Okay. Now if you got a left tail, your p-value is the VFT. If you got a right tail, your p-value is 1 minus the VFT. Well, we got a right tail. So our p-value is going to be 1 minus the VFT. So our p-value is 1 minus 0.9938, which is 1 minus 0.9938, 0.0062. So for a conclusion, got our p-value. Remember, alpha is still the 0.05. This says if p-value is less than alpha, p-value is less than alpha, says you reject H0. So we're going to reject H0, which means we'll accept H1. And since our claim matches H1, that means we'll accept our claim. Now, I show you 4 different methods of solving this, not to confuse you, but depending upon what you're trying to do. If you're using technology, using a TI3, TI4, I'd definitely recommend using one of the two, the classical TI3, TI4, or the p-value approach TI3, TI4. I favor the classical because I like it. But p-value is simpler when you can get to p-value through technology. And now if you're in a class where somebody wants you to do it by hand, then hopefully those steps will help. But for my classes, just use a calculator to do it. And let me save this. And this is to population proportions 0, 1 df. There we go. And time for that to blow up, so let's look at our second problem. Okay. Grab a drink first. Now, we've seen from some of the previous problem that we'll use this same information in all the 4 different techniques. So let me write up here at the top. Okay, in 2008, a study was done asking 500 people if they read at least 2 books a year. 20 responded yes. In 2012, a study was done asking the same question of 800 people, and 45 responded yes. Okay, so we got 2008 and 2012. And we got X1 here and N1 here. X1 would be 20. And this would be 500. And then for 2012, we'll have X2 is equal to 45. And N2 is equal to 800. And it says alpha is 10%. Okay, now we know we're going to need eventually p hat sub 1, and that's x1 over n1, which is equal to 20 over 500. So 20 divided by 500 gives us 0.04. We're also going to need p hat sub 2. That's going to be x2 over n2. Now you don't need this for the calculator, but and this will be 45 over 800. This is by hand, really. So 45 divided by 800. And we get 0.05, 05, 625. And we also need p hat, which I think was x1 plus x2 over n1 plus n2. Well, x1 was 20, so we got 20 plus 45 over 500 plus 800. So that gives us 65 divided by 1300. .05. Well, that seems to come out pretty nice. Okay, so now let's look at our problems. Our first one is going to be the classical, using the T83 84. So let's see what the problem says. Okay, study design asks the same question as are the proportions different at alpha is equal to 10%? So is P1 different than P2? Well, different than is a not equal to symbol. So P1 is not equal to P2, and this will be P1 is equal to P2. And that matches that. I'm kind of jumping ahead. Let me go back to my... There we go. Write down shortened version of the claim. Got that. Come up with null and ultimate hypothesis. We just did that. See if claim matches H0 or H1. It matched H1. Draw the picture. Not equal to is two tails. Open my window here. Okay. Now we want to split alpha into our tails. Alpha is 10%, so I'll put 0.05 in each tail. And if 10% is in the tails, then 90% is in the main body. And we'll have this critical value, and we'll have this critical value. For this, using TI3, TI4 classical approach, we find the critical values use 9V norm. INV norm is based upon the area to the left. So if I look at this first one here, the area to the left is 0.05. For our other one, for this one on the right side, the area to the left is 0.05 plus the 0.90. So you have to add everything together. So that gives us 0.95. So the second vars, INV norm, 0.05, negative 1.645. This will be a positive 1.645. So this one's negative 1.645, and this is positive 1.645. Now test statistic we get with 2 prop z test. So let's go do that. Go to stat, go to tests. 2 prop z test is number 6, so choose that. And x1 is 20. N1 is 500. X2 is 45. N2 is 800. The symbol on H1 was a not equal to, so I want my flashing cursor on not equal to and press enter. And then down arrow and choose calculate. So our test statistic is z is equal to negative 1.31. It's the z equals off the screen. Okay, now this is the number line. Here's negative 1.645. Here's positive 1.645. Negative 1.31 would fall in the middle here somewhere. So for a conclusion, if test statistic falls in the main body, you accept H0. So we're going to accept H0, which means we'll reject H1. They're opposites of each other. And our claim matches H1. So whatever we say about H1 is what we say about our claim. So we'll reject our claim. Okay. Well, let's look at it using the classical by hand. And let me turn to those. Classical by hand. I had to shut my window a little bit. Get too much air blowing on my microphone, and it sounds like I'm in a wind tunnel. Feels good though. Okay, all this first part is the same, so I'm just writing it down again. Still a two tail. Split up our alpha into our tails. Doesn't change. This is a critical value, and this is a critical value. Okay. Oh, and our claim matches H1. First part of these are the same. So that's where we're at. See where we're at. Drew the picture. Okay, we're ready for a critical value. It says use standard normal distribution table. So we're going to first find this one on the left. Now, standard normal distribution table, we look to the area of the left, which is a 0.05. And I'm going to look in the middle, and I'm looking for 0.05. As close as I can get to it. Probably won't be exact. Here's 0.0495, here's 0.0505. It's halfway in between those. So I come over here, negative 1.6. And it's halfway in between these. If I come up here, it's 0.04 and 0.05. So this would be 4.5. Now for this one, we're looking for the area of the left, which is 0.05 plus 0.90, so 0.95. So I'm looking for 0.95 in the middle. Here's 0.9495, here's 0.9505, so it's halfway in between those. I come over there, that's 1.6. And you can probably guess what this is, 4.5. Again, it's halfway in between these hundredths place. So, you know, if we average these, 0.04 and 0.05, we get 0.045. That's why you put the 4.5 here. Okay, so those are our critical values. Now our test statistic. We have to use this formula. So we've got Z naught equals P hat sub 1 minus P hat sub 2 over square root of P hat times 1 minus P hat. Then the square root of 1 over N1 plus 1 over N2. Now I've calculated some of those up above just to make it a little cleaner down here. P hat sub 1, that was 0.04. Minus P hat sub 2. P hat sub 2, that's 0.05625. 0.05625. Then the square root, P hat, what's P hat? 0.05. So 0.05 times 1 minus 0.05. Then the square root of 1 over N sub 1, which was 500, plus 1 over 800. Okay, let's see what that gives us. Have to be careful when plugging in the calculator. I want to put parentheses around top, parentheses around the bottom. So the beginning parentheses, 0.04 minus 0.05 625, close parentheses, divided by beginning parentheses, then second x squared for our beginning square root, and then 0.05 times beginning parentheses 1 minus 0.05. Closing parentheses on 1 minus 0.05. Closing parentheses on that square root. Then times, and then our second square root, which is square root of 1 over 500 plus 1 over 800. So I got 1 divided by 500 plus 1 divided by 800. Enter. Now we get negative 1.31. Does that look familiar? So we came up with it right here. It should be the same, or very close. Well, I think it'd almost be exact, but okay, this is the number line. Here's negative 1.645. Here's positive 1.645. Negative 1.31 will fall in there somewhere. So our conclusion, test statistic follows the main body except H naught. So that means we'll accept H naught, which means we'll reject H1. And since our claim matches H1, that means we'll reject our claim. There we go. Now again, these formulas I did up here, p hat sub 1, p hat sub 2, and p hat, I did just for the by hand calculation. You do not need to do that for the calculator. Let's see how I'm doing in space here. Not good. Okay, that one doesn't take up much space at all. And this one shouldn't be too bad either, because I've calculated Z0 already. Okay, so let's look at this. This will be the p-value using the TI-83 84. And our claim is P1 different than P2. So P1 different than P2. So we got P1 is not equal to P2 and P1 is equal to P2. And that matches H1. Not that we need it, but it's two tails. Okay. See if your claim matches. Find a p-value. It says 2 prop z-test. So we're going to find the p-value using 2 prop z-test. And I think alpha, what was alpha? 10%. Alpha's 10%. Let's write that down. So 2 prop z-test. I got my numbers already filled in for that, so I'm fine. If I do stat, go to test, 2 prop z-test, choose 6. Again, it has all my numbers in there I need, so I just calculate. This time, instead of looking at the z equals, we look at the p. That's our p-value. So our p-value is equal to 0.1909. Like that. Okay, if p-value is less than alpha, well, this is not less than alpha. Alpha is 10%. This is like 19%. If p-value is greater than alpha, it says you accept H naught. So our conclusion is we accept H naught, which means we reject H1, which means we reject our claim. Okay. Well, now let's do the p-value by hand. Okay, so our claim is P1 is different than P2. And we got H naught is P1 is equal to P2, and H1 is P1 is not equal to P2. And that matches that. Okay. Now come up with null and alternate, see if claim matches that. Find a test statistic. Well, I'm not going to do this formula again. It's the same one as up above. Well, actually, let me jot it down. So we got 0.04 minus 0.05625 divided by square root of 0.05 times 1 minus 0.05 times the square root of 1 over 500 plus 1 over 800. And just like up here, we get negative 1.31. Okay, so we found our test statistic. Now look up the z-score from step 4 in a standard normal distribution table. Find the value from the table. Value from the table. So I got negative 1.31. So I come over here to negative 1.3 on the left side, right there. And our hundreds place is the 1, so we'll look in the 0.01 column. So negative 3. Was it negative 3.1? Yeah. Negative 3.1 would give us 0.0951. Okay, this is two tails. So if I come over here, I go down two tails, and it says if p-value is, or if the VFT is less than or equal to 0.5, which is less than 0.5, p-value is 2 times that. So P is going to equal to 2 times VFT. So 2 times 0.0951. So 2 times 0.0951. And we get 0.1902. You notice using technology and doing it by hand don't come out precise, but this is something we have to deal with. Okay, our conclusion. If p-value is less than alpha, it's not less. If p-value is greater than alpha, we accept H naught. So our conclusion is we accept H naught. That means we reject H1. And since our claim matches H1, whatever we say about H1 is what we say about our claim. So we'll reject our claim. And those will be our answers. So let me save that. And that shows you the 4 different ways of doing claims when you're talking about independent. Now we'll be looking at dependent here in a little bit, but let me grab a drink. Next we're going to be looking at confidence intervals. I'm going to come back to all that. Let's go down to our problem. Okay. Says, in a poll of 1,000 men, 200 said they believe in UFOs. In a poll of 780 women, 100 said they believe in UFOs. So I got men. So I got X1 is equal to 200. And I got N1 is equal to 1,000. And for women, I got X1 is 100. X1. Let's try it again. X2. And N2 is equal to 780. I'll write that 200 a little bit neater. Okay. And it says construct a 95% confidence interval for the difference between the two population proportions. So P men minus P women. And 95% confidence interval. Okay, now let's go back to these. Well, we have this one, which is our by hand. And so let's look at that first. So by hand. First thing we need to do is find Z alpha divided by 2. That's not 2 divided by 2, that's alpha there. That's this symbol right here. Well, we have this. We put 95% in the middle. Whenever we're asking, take whatever the confidence interval is, they put in the middle. And we're going to put 5% in tails. So this will be 0.025, and this will be 0.025. Now the Z alpha divided by 2 is this value right there. So we're going to use INV norm to get, wait a minute, by hand. Okay. So we're going to use our standard normal distribution table for this. You look at the area to the left, which is 0.025 plus the 0.95. So we're going to look up 0.975. So used to doing things on the calculator. I probably haven't done this by hand for 25 years. Back when I took stats, way back when. So 0.975. What I do for fun on Saturday night. Wild times at my house. Here's 0.975. It's exact. Okay, so here's 1.9. And that come up here and it's 6. So that's 1.96. So our Z alpha divided by 2 is equal to 1.96. Okay, well, then it looks like we need P hat sub 1, P hat sub 2 for both formulas, or the lower bound and upper bound. So 2, I want to find P hat sub 1 and P hat sub 2. P hat sub 1 is equal to x1 over n1, which x1 is 200 over 1,000. I think that's 0.2. I'm not very good with decimals. Let me go check that just to make sure. 200 divided by 1,000. Boy, I was wrong, wasn't I? Oh, I did 10,000. Let's try it again. 200 divided by... Better go to bed. 0.2. Look at my seeing eye dog. Okay. And then P hat sub 2 is going to equal to x2 over n2. x2 is 100 over 780. So P hat sub 2 is equal to 100 divided by 780. Not very nice. 0.1282 05 1282. I could just leave it as 100 over 780. It might be better, but oh well. So then, from our formula, our lower bound is going to equal to P hat sub 1 minus P hat sub 2 minus Z alpha divided by 2 square root of P hat sub 1 times 1 minus P hat sub 1, all over N1 plus p hat sub 2 times 1 minus p hat sub 2 all over N2. Well, this would be p hat sub 1, which is 0.2, minus p hat sub 2, which is that long number, 0.1282051282, minus z alpha divided by 2, which is 1.96, and the square root of p hat sub 1, which is 0.2, times 1 minus 0.2, divided by n1, which was 1,000, plus p hat sub 2, which is 0.1282051282, times 1 minus 0.1282051282 all over N2, which was 780. Okay. Now I probably have that value stored right here. So I'm going to press my store button, and I'm just going to press my X key. I'm going to store it in X and press enter. So now anytime I want to type in that number, all I have to do is type X. Okay, so let's type this in. I've got beginning parentheses, 0.2 minus, and that's that long number, so I'll put X, close parentheses, minus 1.96, and then a square root, so we do second X squared, and then this. So I got, well, this is kind of tricky to type in. This would actually work if we just type it in without putting parentheses on the top, but that kind of goes against what I've told you earlier. So let me put parentheses on the top of the fraction. So beginning parentheses on the top of this fraction here, 0.2, then beginning parentheses 1 minus 0.2, closing parentheses on that, the 1 minus 0.2, closing parentheses on top part, divided by 1,000. Plus, then over here, again I'll put parentheses around the top part. So the beginning parentheses, we got that long number, so X, beginning parentheses 1 minus X, close parentheses on the 1 minus X, closing parentheses on top part, divided by 780. It'd be a miracle if I typed that incorrectly. And we get this. And I'll take it to 4 decimal places. 0.0377. That's our lower bound. Okay, upper bound. Upper bound is pretty much the exact same formula. Everything's the same except for this is a plus here. So we're going to have p hat sub 1 minus p hat sub 2 plus z alpha divided by 2, the square root of p hat sub 1 times 1 minus p hat sub 1 over n1 plus p hat sub 2 times 1 minus p hat sub 2 over n2. So our upper bound is going to equal to 0.2 minus 0.1282051282 plus 1.96 square root of 0.2 times 1 minus 0.2 divided by 1,000 plus 0.1282 051,282 times 1 minus 0.1282051282 all divided by 780. not a necessarily hard formulas. Just typing it in correctly in the calculator is a nightmare. So you might want to do it in pieces. Do this separately. Write it down. Do this fraction separately. Do this separately. You have to find what works for you. Now I'm going to do a second enter to bring up the previous entry. And I'm just going to change the plus or the minus to a plus. And enter. And that gives us the 4 decimal places, 0.1059. Assuming it worked, then our answer will be, and we're going to check that here in a minute. I don't guarantee that I didn't screw something up on that, but that would be our answer. Okay, well, how do we check it? Well, do it on the calculator. Calculator is very easy. So we'll go to our Stat button, right arrow to test, and we want to down arrow and choose 2 prop Z end. I think it's next to B. You probably do an up arrow to find it faster. Okay, there's 2 prop Z end. Do enter on it. And we want X1. X1 was 200. We want N1, which is 1,000. We want X2, which is 100. And we want N2, which is 780. C level, which we want 95%, so I'll put in 0.95 and choose calculate and enter. Oh, I'm really grateful for that. Gives you the same value. See, here's our confidence interval. So that is indeed our answer, using by hand or by calculator. Let me save that. I was looking for where it screwed up typing in the calculator. So you can probably guess which way I think you should do it. Do it on the calculator. There's no benefit to doing this except for making an error in business. Let's say you're going to work for a business and you're trying to calculate this. Well, you're going to be operating off of a mathematical mistake. So use calculator. Use technology whenever possible. Excel, so forth. Did I just say that? I was talking when I should have been paying attention. I think that's 8:15. Yep, that's one. I don't know why this is blowing up so much. Maybe it's tired and wants to go to bed. Okay, so that's our confidence intervals. Now let's take a look at testing a hypothesis regarding the difference in 2 proportions. And this is dependent samples. And the book explains this. And one particular example I thought of is like if you got a skin condition and you put cream, one particular cream on one arm, a different cream on another arm, and you're testing it. And you're testing the success or failure. Well, that's what this indicates. So this F11 here refers to both of them worked. The treatment A was successful and treatment B was successful on both arms. Or the F12 was treatment A failed and treatment B succeeded. So you can see all the different possibilities there. Now to test the hypothesis regarding 2 population proportions, P1 and P2, that should be P sub 1. I'll eventually have it perfect. Subscript. There we go. Save that. Where the samples are dependent, arrange the data in a contingency table as follows. Now this F11, F12, that sub 11, that refers to row column. So row 1, column 1. This is row 1, column 2, row 2, column 1, and row 2, column 2. Now requirements to do this, let me grab a drink actually. Samples are dependent and are obtained randomly. Total number of observations where the outcomes differ must be greater than or equal to 10. That is, f sub 1, 2 plus f sub 2, 1 is greater than or equal to 10. And I'm not going to go over those. Let's go down to our problem. I just made up an example. It doesn't have any kind of meaning. I'm not very good at making up problems. Okay. I'll put UFOs. Excuse me. And no UFOs. This refers to belief. And then over here, this was ESP and no ESP. And again, this is belief. No means you do not believe in it. Okay, and there's our contingency table. We got 100, 400, 200, and 300. So 7, 9, total of 1,000. Okay. Given a survey, they are asked whether they believe in UFOs and whether they believe in ESP. Given the table below, is there a significant difference in the proportion of adults who believe in UFOs and believe in ESP at alpha is equal to 5%? Okay. As far as I know, there's no way to do this on TI3, TI4. So it's by hand. So let's go up there. Classical approach. Write down a shortened version of the claim. It's always a difference. So the P1 is different. Then P2. Come up with a null and alternate hypothesis. By the way, this is our success and this is our success. So what we're looking at is the UFOs and ESP. Okay. And if you read the problem, I mean that's what it refers to. Is there a significant difference in the proportion who believe in UFOs and believe in ESP? So this is a believe number right here. Okay. So this will be P1 is different. That's not equal. P2. So this matches H1, of course. And this will be P1 is equal to P2. It says draw the picture. Always two tails and split alpha into the tails. Alpha is 5%, so I'll split alpha into the tails. So I'll put 0.025 here, 0.025 here, and 5% in the tails, and 95% in the middle, like that. It says for critical values, use INV norm. So, our left one, the area to the left is a 0.025. And, well, I guess I am using the calculator a little bit here, aren't I? I could use the tables, but it gives the same thing. And this one, the area to the left, would be the 0.025 plus the 0.95. So that gives us 0.975. Second, vars, INV norm, 0.025, enter. And then we get negative 1.96. And this would give us positive 1.96. Now, if I was using the tables, let me just show it real quick. I'm looking up 0.025. 0.025, 0.02, 0.02. I have trouble finding things. Here's 0.02. Here's 0.025. I come over here, it's negative 1.9. If I go up, it's the hundredths is 6. So that gives me my negative 1.96. Okay, our test statistic. I should have wrote that down. Negative 1.96 and 1.96. So for our test statistic, we're going to use Z naught is equal to absolute value of F12 minus F21 minus 1 over the square root of F12 plus F21. Okay. Now F12, that's row 1, column 2. So row 1, column 2 would be 400. So that's 400. Minus, this is F21, that'd be row 2, column 1. It's rows and columns. So row 2, column 1, row 2, column 1, which would be 200. Minus 1 over the square root of 400 plus 200. Well, 400 minus 200 is 200. An absolute value of 200 is 200. Minus 1 gives us 199 over the square root of 600. Probably beneficial to simplify a little bit if it's easy like that before you plug in your calculator. It's 199 divided by the square root of 600. And we get 8.12. That's our test statistic. Well, here's our number line right here. Here's negative 1.96. Here's 1.96. 8.12 will fall over here. It'll fall in our right tail. So for our conclusion, it says if test statistic falls in a tail, reject H naught. So we're going to reject H naught, which means we'll accept H1. And I think our claim matched H1. It always does for these problems. So that means we'll accept our claim. And I'll come back to that, but is there a significant difference in the proportion of adults who believe in UFOs and the ones who believe in ESP? And the answer there would be yes. Yes, there is. So we accepted that. Okay, let's look at it using the p-value approach. I would just recommend, though, doing the classical if I was doing it. So our claim is P1 is different than P2. All this is still the same. P1 is equal to P2. H1. P1 is not equal to P2. Claim matches H1. It's a two tails. Keep that in mind. Well, then it says find your test statistic. So our test statistic will be the same as the one we just found. It's the absolute value of F12 minus F21 minus 1 over square root of F12 plus F21. Which I'm not going to plug those numbers in. They're the same as the other one. We get 8.12 again. There we go. Okay. Then it says look up the z-score from step 3 in the standard normal distribution table and find the value from the table. Well, this one's not going to work out very pretty because 8.12 is definitely not on here. 3.49 is my highest one, which would be 0.9998. 9998. Okay. So then it says if we're dealing with two tails, which we are, if the value from the table is greater than 0.5, which it is, p-value is 2 times. So 2 times 1 minus value from the table. It's 1 minus this, which is going to give us 4e to the negative 4, which my decimal point would be here if I had one, and I move it 4 places to the left. So it'd be 0.1234. Okay, if p-value is less than alpha, well, it's definitely less than alpha. I don't remember what alpha was, but 5%, 10%, what was it, 5%. So alpha is 5%. So p-value is less than alpha. It says reject H naught. So our conclusion is we reject H naught, which means we accept H1, which means we accept our claim since H1 matches our claim. Now this is also referred to as I didn't write it down here. There it is. McNemar's test. If I'm saying his name right, not butchering it too much. He probably went to all that work to come up with this test, and I'm sitting there butchering his name. Okay, so this would be 4. And let's go on. Sample size. Last thing. Okay, sample size for estimating p sub 1 minus p sub 2. The difference between them. That's what we're trying to estimate. Okay, a sample size necessary to obtain a confidence interval is given by n equals n sub 1 equals n sub 2. So it's the same. You know, like if we had one for men, one for women. If I found n was 50, then we'd pull 50 men, 50 women. And it's equal to p hat sub 1 times 1 minus p hat sub 1 plus p hat sub 2 minus 1 minus p hat sub 2. And then all that times z alpha divided by 2 over e squared. Or assuming no prior estimates known, that's if you're given a prior estimate. Assuming no prior estimates known, then it's this next formula, 0.5 times z alpha divided by 2 over e squared. Always round up, and e should be in decimal form. So let's look at a problem with that. Now notice our formula, on both of them we need e and we need z alpha divided by 2. So we're gonna find those. Okay, we want to determine the difference in proportion of men versus proportion of women who believe in UFOs. What sample size should be obtained with 95% confidence within 5 percentage points? Well, E is equal to 5%, and we want that in decimal form, so it would be 0.05. Now, 95% confidence. "95% confidence" means you put 95% in the middle. Split the 5% in the tails. This will be 0.025, and this would be 0.025. And this value right here is our z alpha divided by 2. Now, if you're using the calculator, you'll use INV norm, and it's based upon the area of the left. Well, the area of the left of this is 0.025 plus a 0.95, 0.975. So do second vars, INV norm, 0.975. Then we get 1.96. So that's what Z alpha divided by 2 is. Now if I was using the tables, doing it completely by hand, I'd still look up the area to the left, which is a 0.975. And I look in the middle here, I'm looking for 0.975. Here's 0.975. Come over here, it's 1.9. And if I go up, it gives me the 600s. So that gives me the same 1.96. Okay, so part A says, assume a prior estimate of 20% for men and 17% for women. So men's 20%, women is 17%. That's our prior estimate. So it doesn't matter which one you say is p hat sub 1. So I'll just say this is p hat sub 1 in decimal form, so 0.20. And this will be p hat sub 2 in decimal form, which would be 0.17. And our formula is n is equal to n sub 1 is equal to n sub 2 equals p hat sub 1 times 1 minus p hat sub 1 plus p hat sub 2 times 1 minus p hat sub 2 times Z alpha divided by 2 over E squared. Okay, so let's plug in what they give us. Remember, E up here we said was 0.05. And we said Z alpha divided by 2 is 1.96. Now it'll be the same for both part A and part B. Okay, so P hat is 0.20 times 1 minus P hat, so 1 minus 0.20, plus 0.17 times 1 minus 0.17 times Z alpha divided by 2, which was 1.96, divided by E, which was 0.05. Now I made these numbers up, so if we come up with weird results, don't be surprised. You think I'd plan ahead and actually work all the problems I made up, but no, not that much. To me, that's kind of boring. Part of the fun is seeing what you find when you work the problem. See, closing parentheses and a 1 minus 0.17, closing parentheses and all that, times beginning parentheses 1.96 divided by 0.05, close parentheses squared. And we get 463. You always round up. No matter what the decimal is, if you got any decimal, you round up. And that's our N, N1, and N2. Now, let me double check that. Parentheses wise, yeah, it looks right. Okay. Now B is where you're given no prior estimate. It's our second formula here. So N is equal to N1 is equal to N2 is equal to 0.5 times Z alpha divided by 2 over E squared. So I got 0.5 times 1.96 divided by 0.05 squared. So 0.0, was it 0.05? 0.5. Oops. Back. Then times 1.96 divided by 0.05 close parentheses squared. And we get 769. And that's N, N1, N2. And that actually is the last of that section, I believe. Yeah. So let me save this. And stop the different recorders.